Hello everybody. Today we're going to start taking a look at our second master check, this trigonometric problems and solving trigonometry in right triangles. So what I'm going to do is I'm going to go ahead and do the left side of this page here and leave the right side for you to practice. That way you have a good reference to go back to so that you can also try it yourself. So taking a look over here, this first one right here, it says that we have this triangle and they've given me all three sides. Now this one is a little bit easier than the one on the right. And you need to make sure that you need to be able to do both, which again, if we're doing the easy one together, you should be able to do the harder one on the right. You're going to be set for this mastery check. But on the right, you can see that one of the sides is missing, right? They don't have this side over here. Whereas over here, I have all three of them already. So over in this one over here, you're definitely going to have to do Pythagorean theorem to find this missing side, and then you can solve it. So if you need help with that, please come talk to me or one of us so that we can help you out. But over here, we have all three sides. So let's go ahead and figure out how we're going to label this. We're going to put all three sides together. So we know that across from our 90 degrees is always going to be that hypotenuse. So we're going to put our hypotenuse over there. And then it just depends on which one we're focusing on. So let's start by using blue. So for the first three problems, we're solving using W, meaning our angle of reference is at W. With that being the case, that would mean the 24 being next to theta right here, that happens to be the adjacent side. And since the 32 is not touching it, the 32 would be the opposite. So when I go to put this together, remember we're going to use our little phrase up here, SOHCAHTOA. Very important that you remember that. SOHCAHTOA. So we know for SOHCAHTOA, we know that the sine is the opposite over the hypotenuse. So for sine of W, we're going to put opposite over hypotenuse. So let's figure out what that's going to be. The opposite is 32. The hypotenuse is 40. And I definitely see that both of those things are simplifiable. I could take both of those numbers and I could divide them. Let me write it up here. I could divide this by 8 and divide this by 8. So 32 divided by 8 is going to give us 4. And 40 divided by 8 is going to give us 5. So technically, let me erase this actually. We don't want that down there. We want the 4/5 down there. All right, for the cosine, I'll put an S here. Cosine, well, we know that cosine is the adjacent over the hypotenuse. Cosine is adjacent over hypotenuse. So we're going to put the adjacent side, which is 24, over the hypotenuse, which is still 40. And again, both of these are still divisible by 8. So when I do that division, 24 divided by 8 is 3. 40 divided by 8 is 5. So the cosine is going to be 3/5. And last, we've got our tangent here. Tangent is going to be the opposite side divided by the adjacent right here. Opposite over adjacent for tangent. So when I do the opposite, I get 32 over the adjacent of 24. Again, both divisible by 8. And I end up with 4/3. All right, so with that said, we're going to now go and do the U side. So I got to switch to focusing on U. So that means theta now moves over here. And what that's going to do is it makes this adjacent, this opposite not correct anymore. Now the 32 is adjacent to theta because it's next to theta. And the 24 is opposite because it's across from theta. So it's going to change a couple things, but that's okay. We probably don't even need this much room over here because you're going to see a lot of the numbers pop up again. So when I do sine, we know sine is opposite over adjacent, so the new opposite is 24 over the hypotenuse, which is 40x, and I think I said opposite over adjacent. I meant opposite over hypotenuse. You can see that we get 24 over 40. Look at that. 24 over 40 was the cosine here. So we already know 24 over 40 is going to simplify to 3/5. So I know that the sine of U is 3/5. In other words, the cosine became the sine up here. And that's always going to happen. We've talked about that. All right, for the next one, the cosine is adjacent over hypotenuse. The adjacent is 32 and the hypotenuse is 40. Again, we've seen that before. 32 over 40 was up here, which then becomes 4/5. So I now know that the cosine of U is 4/5. And again, like we said before, the sine becomes the cosine of its complementary angle, and the cosine becomes the sine. So they just switch places. The tangent does something a little bit different, though. Tangent, we're going to put opposite over adjacent. So the opposite is 24 over the adjacent 32. There's not a lot of room here for me to do this division, but you can see that both those numbers would be divisible by 8. So 24 divided by 8 would give us 3. 32 divided by 8 would give us 4. And you can see that the tangent and the tangent of the complement are just reciprocals of each other. We just flip that fraction upside down. So you could shortcut that. If you know those steps and know those rules, you could definitely shortcut it. You don't have to take your time to do that. So do what works for you and what you know. All right, going on to this next one, we're gonna now find the missing side in level 2. So in level 2, we gotta figure out what the missing side is, which means I'm gonna need to label my 3 sides right away. So what I'm gonna start by doing is identifying my angle of reference. So in this case, my angle of reference is this 59 that they gave me. The angle of reference is always the angle they gave us. Labeling my 3 sides, across from the 90, hypotenuse. Next to the angle of reference has to be adjacent, and across from the angle of reference is always the opposite, the one not touching the angle. In this case, we get to get rid of one of these. There's one side that doesn't have a variable or a number, and in that case, it's the hypotenuse. There's nothing on this hypotenuse side. We see that the adjacent has the 59, the opposite has the x, but the hypotenuse has nothing. So I'm gonna take the hypotenuse and cross it out. We don't want it. So thinking about our TOA, we need to decide if we have an opposite with x and an adjacent with 5.9, which trig function uses a and o. And we can see right here, a and o is on TOA, which means we're using the tangent function. So we know we're using tangent of theta equals the, I don't know what that was, equals the opposite over the adjacent. So we're just gonna plug in that stuff there and solve this problem. So theta becomes the angle that we are given. So in this case, tangent of 59. And the opposite is x, and the adjacent is 5.9. And what we do is we add this invisible 1 down here, right? We put a 1 on this tangent, and we cross multiply. So 1 multiplied by x is gonna be, let me switch back to the purple, is gonna be x. And then tangent of 59 times 5.9, well, that's going to go in our calculator. 5.9 multiplied by the tangent of 59. So I'm going to type exactly that in my calculator. 5.9, let me actually write out the buttons here in case you don't know them and you're still struggling. So we'd put 5.9 in our calculator. We'd press the multiply button. We'd type 59 in, press the tangent button, and then equals. Those are the steps that I'm putting in my calculator right now that you can't see. Tangent equals, and I get 9.82. So x equals 9.82. Being very mindful that if you got a different answer, let me tell you what that answer is right now. If you ended up getting 5.9 times, if you got negative 4.87, it means your calculator is in the wrong mode. Make sure you put your calculator in degrees when you start this test. That way you don't mess these up. So 9.82. All right, level 3, same idea, same question. Find the missing side. We're gonna see something a little different happens here, but let's label our 3 sides. So across from our 90, hypotenuse. Circling our angle of reference, the side next to it is the adjacent, and the side across from it is the opposite. And in this case, the one that I want to cross out looks like it's the adjacent because there's nothing over there. So I have an O and an H. I'm going to come back up here. With O and H, I see that's the sine function. Sine is O and H. So we're going to do sine of theta equals opposite over hypotenuse. All right, plugging our stuff in here. Theta is going to be 37, so sine of 37. The opposite side is 0.6. And the hypotenuse is x. So again, putting this invisible 1 here and cross multiplying. 1 multiplied by 0.6 is 0.6. And on this side, sine of 37 times x, I'm going to put the x first. X times the sine, and then in parentheses 37. So I know that to solve this, we're going to need to divide both sides by sine of 37. And we're going to put that in our calculator to get our answer of what x equals. Again, doing the exact same buttons as up above. Put the number in, but put divide this time, and then put 37 sine. So 0.6 divided by 37 sine equals, and I get 0.996. So I guess that would round to 1, right? 0.996 is going to round to 1. Nice answer. X equals 1. All right, and on this last example, this one says solve for the missing angle. So very similar to what we just did. We're still going to circle the angle of reference, which is the variable we're looking for, and label our three sides. So across from this 90, hypotenuse. Next to the x is the adjacent, and across from the x is opposite. So in this case, the one I get to cross out is opposite. So going back and thinking about SOHCAHTOA, I know this is going to be CAH. A and H, I have an adjacent and a hypotenuse. So I'm using the cosine function. Cosine of theta equals the adjacent over the hypotenuse. So plugging in the things, well, the problem is this time the missing variable is theta. So cosine of x equals the adjacent side is 7.2 and the hypotenuse is 9.4. Well, in this one, when this situation happens where you can't cross multiply because the trig function is the piece that's wrong, the trig function is the piece that we need to find, what we do is we move this to the other side. But when I move it, x stays by itself, and when the cosine moves to the other side, it becomes the inverse of cosine. So all we're going to type into our calculator is we're going to put, and I'll write this, let me write this up here, 7.2 divided by, we're going to put our 9.4, and we're going to press equals right away, and then we press the second button, which on my calculator is that green button if you're using the class calculator. Second, and then you press the trig function, in this case, cosine. So I'm going to type that in right now, 7.2, 9.4, nope, it didn't take it, 7.2 divided by 9.4 equals, and then second cosine, and I got 40.007, so I'm going to round that to 40 degrees. And that would be our answer. Hopefully this helps. If you have any questions, please reach out. Have a great day.